Dear Professor, hello everyone. I'm wanghongyu. My metric number is 23304499. Today, I'm honored to present my thesis titled Predicting House Prices in Kuala Lumpur using Explainable Machine Learning Models. This study was motivated by the fluctuation and the disparities in property prices across different areas in Kuala Lumpur and the rapid urbanization. Accurate and interpretable house price prediction is vital not only for home buyers and investors, but also for financial institutions and policymakers. In the statement of the problem, I emphasized the need for a model that is both accurate and interpretable. The target was to predict house prices as accurately as possible based on various features, with an encouraging goal to keep the RSE under 50,000 ringgit. The main objectives of this study were to collect and pre-process housing data from Kuala Lumpur. 2. Build and compare multiple machine learning models. 3. Evaluate model performance using RMSE, R square, and MAE, and so on. 4. Apply explainable AI techniques such as SHAP. 5. Provide actionable insights for stakeholders. Literature review. In the literature review, I studied multiple relevant works that adopted various methods to predict house prices. Linear regression has been widely used but often lacks accuracy in handling multivariate relationships. Recent studies often use tree-based models such as random forest and XGBoost, or even deep learning models like TableNet, which offer higher accuracy but limited interpretability. Moreover, while there have been some studies on house prices in Malaysia, few have incorporated geospatial features such as the distance from properties to MRT stations or hospitals. This led to the identification of a research gap. Although machine learning has been applied to house price prediction, few studies have combined the local features, geographic data, and explainable AI to study Kuala Lumpur's real estate market. Filling this gap became the core contribution of my research. I built on traditional housing attributes and integrated spatial features using Google Maps API, combined with SHAP for explainability. Research methodology. This study followed a structured research pipeline. Data collection. The dataset was scored from Kaggle and contains over 57,000 housing records from Kuala Lumpur. Data processing. I removed or imputed missing values, standardized data formats, applied algorithmic transformation to skewed variables, and used the Harvison formula and the Google Maps API to engineer features such as the distance to the nearest MRT, school, and hospital. Totally, I tested six models, include 1. Multiple linear regression, 2. Ridge regression, 3. Random forest, 4x ski boost, 5 cat boost, and the last one TapeNet, a deep learning model for structured data. Evaluation metrics include RMSE, R square, MAE, and MSE were used to assess performance, with a special focus on balancing accuracy and interpretability. Last one is explainable AI, SA, SHAP. Values were used to explain how each features influence predictions. Results and findings. The results showed that the random forest had the best performance among all six models, achieving training R square is a 0.98, testing R squared is a 0.92, RMSE is a 47,000 ringgit, which is below the target of 50,000 ringgit. This indicates that the model had high accuracy and strong predictive power. ASCII Boost also performed well with an R-square of 0.92. Consistent with existing literature, linear regression was the least accurate, although aligning with previous studies. Discussion and implications. The results confirm the effectiveness of ensemble methods, especially random forest, in predicting house prices. Compared with linear models, they better captured complex patterns and feature interactions. These findings align with previous research, emphasizing the roles of structural and geographical variables in real estate valuation. This study offers a new theoretical framework by integrating spatial engineering and explainable AI in property modeling. It serves as a reference for future studies in Southeast Asian real estate markets. Particularly implications. Real estate companies can set more reasonable pricing strategies. Banks can use the model for loan risk assessments. Urban planners can better understand how infrastructure affects housing values. In conclusion, this study successfully developed an interpretable model for predicting house prices in Kuala Lumpur. It filled a research gap by combining spatial data, ensemble models, and SHAP explanations, achieving the RMSE target below 50,000 ringgit, offering practical and transparent insights to real-world stakeholders. That's my presentation. Thank you for your attention.